So it says which functions whose graph below has a non-zero average over the closed interval negative pi to pi, and it says recall that the average value of a function on a to b is given by the following formula. So let's go down here and synthesize that information and then use that to then figure out which graph is appropriate. So the interval a to b that we were given is negative pi to pi. The formula for average value is 1 over b minus a times the integral from a to b of f of x dx. So let's plug in our numbers. So we're going to have 1 over pi minus a minus pi, so that's going to give us 2 pi, times the integral from negative pi to pi of f of x dx. So we want to know which of the graphs provides a non-zero answer to this integral. So the 1 over 2 pi is not going to be the problem. We need to determine which one of those graphs has 0 net area from negative pi to pi. So in order to do that kind of efficiently, when the bounds of a definite integral are the same number, so like negative pi to pi, so negative a to a, there's actually a property in math that will help us do this. And so the property is the following. If you have a definite integral whose bounds are negative a to a, that integral is 0 if the function f of x is odd. And what that means, you can visually determine that, is it is symmetric to the origin. So this idea of symmetry is something we learned in like pre-calculus. There's also an algebraic way to test for this, but since we have graphs, we'll stick with this. All right. We also know that negative a to a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx if f of x is even. And you visually determine that by looking if it is symmetric to the y-axis. Now this is important because if we identify any odd functions, their integrals are 0, and we're looking for non-zero results. So we can eliminate any odd functions right away. If the graph is even, it means it's still in contention. So let's first look at these to see what's odd and what's even. So this function is symmetric to the origin, right? And sine of x is an example of a graph that's symmetric to the origin. So this graph is odd, so it's out. This graph is also symmetric to the origin. So this graph is odd, so it's out. This graph is even, so it's still in contention. This graph is symmetric to the origin, so it's odd, and it's out. And this graph is even. So these are the two we need to evaluate. And remember, we need to verify, would the area give us a non-zero result? And if that's the case, then we select it. So from negative pi to pi, the region would be right here. And from negative pi to pi, the region would be here. So if we look at this graph, well, this is clearly a cosine wave. And we can see that this is exactly the same size as this. This is negative area, this is positive area, this is positive area, this is negative area. We have exactly the same amount of positive area as we do negative area. And so this area is going to end up equaling 0, so we can eliminate it. Just to verify that this is going to be the correct answer, well, there's way more negative area than there is positive area, so you'll definitely get a non-zero area. And so if we come back down to our equation, as long as this is non-zero, we're good. So this is the only option, and so E is the answer.